All right, ladies and gentlemen, jumping to our new unit, Unit 13, Lesson 13.1, page 568. A lot of reasons why we're jumping all the way to Unit 13, and I'll explain that to you in class tomorrow. Ladies and gentlemen, we're going to apply what we learned to graph a linear equation using a table of values. Our essential question today: how do you recognize a linear equation and how do you draw its graph? So I know you could probably fill out some of these notes on your own by reading page 568 and 569. However, we're going to spend the next few moments filling it out together and having some discussion. So ladies and gentlemen, in a relationship where one thing depends on another, we have a function. And in a function, one or more operations are performed on one number, that's the independent variable, to get another number, the dependent variable. A relation that pairs each input with exactly one output is a function. In other words, you can have repeated inputs as long as you have different outputs, but you cannot have repeated outputs. Okay? If you have two different inputs and you get the same output, you do not have a function. We'll spend a lot more time on that later. So functions are often written as equations. We spent some time on equations, so let's get busy. Here's one right here. Y equals 2x plus 3. Ladies and gentlemen, now you know in Unit 3 why we spent time with literal equations and why we spent some time with equations that had variables x and y in them. And then we spent more time solving for y. That is because this is the form we wanted in. And we're going to name that form later. It's called the slope-intercept form. I guess I just named it now. But we're going to talk a lot more about that form later. It makes it easier to graph. Right now, we just have this linear equation, y equals 2x plus 3. And in this, we have an input. That input is our independent variable, x. That is some number that we choose to put in, and when we put that number in, we then apply some rule. We're adding, subtracting, multiplying, dividing, any combination of those operations we are doing to that independent variable to get an output, to get some number out. And that output is called the dependent variable. So our output is the dependent variable. Our input is the independent variable. And it only makes sense. We wouldn't put the y in first. I mean, we could. We could put the y in first and we could solve and find out what x was. But it makes more sense that if you have this rule that we're going to pick a number to put in, apply the rule to x so that we get some number out, y. So, ladies and gentlemen, linear equations are equations whose graph is a line. And if you look at the word linear, the word line is in it. So when we use our function table of values, which we can use to organize an input, a rule, and an output, so we get a function table of values that we can then graph what we would get our ordered pairs, our input and output variables. And we can make a line by drawing a line through them. So let's take a look at this one. Y equals x plus 1. And here's a table of y equals x plus 1. And we have our input, x. We're going to apply some rule. Well, we know what that rule was, x plus 1. So we're going to add 1 to it, and then we're going to get an output. So if I put in -1 and add 1, I would get 0. So now I can take those input and output variables and make an ordered pair x, y. -1 in, that's the x, 0 out, that's the y, and then I can come over to the graph, and I can put -1, 0 right here on the graph. Let me get red so you can see. I'm going to put a dot right on it. Right here. Right here is -1, 0. And I can put all those on there and draw my line. Now, ladies and gentlemen, we need to go right back up here where it says, all points on the line are solutions of the equation. Well, you notice that every single point that was in our function table is on the line. And if our graph were bigger, we could continue to follow and we would find more points. But to prove to you that every point is a line, I'm going to go here and I'm going to call my input as 1.5, approximately right here. And if I go up to the line and put a point on it, then I'm going to see what would my output be. Well, right there, that's approximately 2.5. So if I put 1.5 as my in and I add 1, I would get 2.5. Just the same way as if I put in negative 2.5 over here on the x and then draw it down and come down and across, I would have my output as a negative 1.5. So every single point on that line is a solution, even if they are not perfect integers. All right? So ladies and gentlemen, let's spend a few moments actually doing some. We're going to graph y equals x minus 2, and we're going to do some inputs. Now, ladies and gentlemen, let's just pick some easy numbers. We can pick any numbers we want. But one, we want to make sure those numbers and our ordered pairs that we get actually end up on a graph, or we've wasted our time doing math that we don't need. So one of the numbers that's always easy is 1. And we apply that rule, 1 minus 2, and we get negative 1. So now we have an ordered pair of 1, negative 1. So 1 is a great number to always choose. The next number you certainly want to always choose. It's the easiest number ever to do math with, and that is 0. Always choose a 0. And if you put that in here and you go 0 minus 2, well, that's going to give me negative 2. So my next ordered pair is 0, negative 2. Now, ladies and gentlemen, we need 3 numbers. If we only graphed 2 numbers and drew a line, we wouldn't know really if that line was accurate or not. Because if we did our math incorrectly on one of those rules, we wouldn't know. So we want a minimum of 3 points, 3 ordered pairs. So we want to pick 3 inputs. Of course, the next easiest number, if you wanted to have a positive and a negative, would be negative 1. So if I go negative 1 minus 2, I would get negative 3 coming out, and I would have, I would have negative 1, and I would have, let me erase that. I always got to do it nicely. So if I put in a negative 1, I would have negative 3 as my output. So now we have 3 points. So we know if our line goes through all 3 points, we are accurate. So I have these 3 ordered pairs. I come over to my graph. I go to 1, negative 1. I go to 0, negative 2. And I go to negative 1, negative 3. And of course, you guys want to use that straight edge. And when you draw your graph, please, your line should go all the way through the graph. You should put arrows on each end, indicating that it goes on and on and on forever. Now my line is not accurate because I don't have the ability to put a straight edge on my board. Like you can use either your ID card or a small ruler on your paper to draw a real nice line. Because then you would see that every point on that line, well, they are solutions to that linear equation. All right? So moving on to our next one. Graphing y equals negative x plus 3. So again, we just talked about it a moment ago. I'm going to choose 1, 0, and negative 1. They're always the super easy numbers, especially 0. And I'm going to go negative 1 because we have a negative x. Got to remember to put that on there. Plus 3, my output would be 2. My ordered pair is 1, 2. Then if I put in 0, I would have negative 0 plus 3. Yes, we know there's not such thing as a negative 0, but we're going to write it anyway. I would still get 3 as my output, so my ordered pair is 0, 3. Now we're going to put in a negative 1. So we really have to make sure we put that negative because x is negative. And then our x is negative 1, and then we're going to add 3. And so negative 1 is 1, plus 3 gives us 4. Our output, our ordered pair now is negative 1, 4. We come over to our graph and plot these ordered x, y pairs. We have 1, 2, go over up 2. We have 0, 3, and then we have negative 1 and 4. And of course, our graph goes all the way through, our line goes all the way through the graph. We put arrows on each end. We draw it nice and straight, and voila, we have graphed that linear equation. And every point on that line is a solution. Our next one, graphing y equals negative 1/3 x plus 5. This is our last example of the day, but I threw this in here because now that coefficient of the coefficient of the independent variable is a fraction. So now when we choose numbers, we want to be smart. We want to choose numbers that will give us those nice integers that are easier to graph, so we're not guessing where there's some fraction of a number between 2 points. So I'm going to pick a positive one, and I always want to pick, when I have this fraction as my coefficient, I want to pick numbers that are compatible with 3. So numbers like 3, 6, 9, -3, -6, -9. Again, picking ones that will fit on our graph. So I'm going to pick a positive 3. And if I have a -1/3 times 3 plus 5, well, I would get -1 plus 5, which is 4. My ordered pair is 3, 4. Always picking 0, because it doesn't matter whether a fraction or not. Anything times 0 is 0. So -1/3 times 0 plus 5, well, that would give me 5. And so now my ordered pair is 0, 5. And I'm going to pick, because I want a negative, as long as my number ends up on the graph, well, that will work. So I have a -3, so -1/3 times a -3 plus 5. Well, that will give me a +1 plus 5, which is 6. And so now my ordered pair is -3 and +6. And I come over to my graph, and I put those numbers on. I go 3 up 4, bingo. I go 0 up 5, bingo. And I go -3 up 6, bingo. And I can draw my line. They all fit on my graph. Voila. So ladies and gentlemen, a lot of just procedural plug and chug, but there were some things that are important to understand, especially as we move forward. It's going to make a lot more sense with all the things we've done in the past. You have a quick write to do, where you need to write 2 sentences describing the linear equations and all the points on the graph of the equation, and then you have a coordinate grid. You need to make a function table. Now, ladies and gentlemen, you don't have to make an elaborate function table. You can just make this function table looks like that. You can say your x and your y input. You can write your rule above it, y equals -2x minus 1. You can do your math, picking your numbers, 1, 0, and -1. Just going to help you out. Find your outputs and graph. Take a quick break and come and see me for our second video.